In this videotape, you will be shown how the dividing head and the rotary table can be used to accurately rotate workpieces for various machining operations. Both of these devices are used for making divisions in the manufacture of machined parts. After viewing this videotape, you should be able to write down the safety precautions to be observed in the machine shop and when using the dividing head and rotary table, identify the main parts of the dividing head and rotary table, and make calculations and setups for using the dividing head. Some of the safety precautions to be observed are: always wear safety glasses, remove watch, rings, and other jewelry, roll sleeves above the elbows. Setups involving a dividing head or rotary table should be checked for clearance and rigidity. The indexing or dividing head is made up of the following component parts. The body is the large machined part which has the spindle nose, in which a chuck or centers can be mounted. The spindle lock is used to lock the spindle in place for machining. The index plate is the circular metal plate with equally spaced holes drilled in it. The sector arms fit on the front of this plate and are held in place with the sector arm lock screws. These arms are used for positioning the plunger, which is attached to the index crank. The index pin is located on the end of the plunger and is used to position the plunger on the index plate. The footstock is a separate attachment which can be used in conjunction with a center in the headstock to do machining between centers. Direct indexing is the simplest form of indexing. Most dividing heads are equipped with a plate with indexing holes machined in it and an alignment pin. When a part is to be divided into an equal number of spaces, such as 2, 4, 6, 8, or a division of these, direct indexing can be used by turning the chuck, holding the part, and using the aligning holes for reference in making the divisions. Let's demonstrate direct indexing of 4 graduations. Line up the pin with a 0 hole and do your first machining operation. Then turn the chuck and engage the pin in the hole numbered 4. Lock the chuck and proceed with the machining. Unlock the chuck and engage the pin in the next hole numbered 4. Continue this process until you return to 0, your starting point. Simple indexing, also known as plain indexing, involves the turning of the index crank to rotate the spindle. Most dividing heads have a 40-to-1 ratio, which means it takes 40 turns of the index crank to rotate the work through 1 turn. To determine the number of turns of the index crank and holes in a given plate to use in dividing a circle, you divide 40 by the number of divisions desired. The whole number gives the number of full turns of the index crank. And if there is a remainder, this gives the number of holes to rotate the crank in a given whole circle. As an example, let's divide a circle into 20 equal divisions. Divide 40 by the number of divisions, 20, which gives an answer of 2. This means that indexing the circle after every 2 full turns of the crank will lay out 20 equal divisions around the circle. If a circle is to be divided into 5 equal parts, it would be indexed after every 8 turns of the crank. Now, if you wanted to use simple indexing to divide a circle into 6 equal graduations, you would divide 40 by 6 to get an answer of 6 4/6 turns. To find the number of holes required for the fraction of a turn, look for a plate whose number of holes can be evenly divided by the denominator of the fraction. The dividing head is equipped with an 18-hole plate, and 18 is evenly divisible by 6 to give an answer of 3. Now multiply the 3 by 4, the numerator of the fraction. This gives 12, which is the number of holes to be indexed on the 18-hole plate for 4/6 of a turn. Make 6 complete turns plus 12 holes in the 18-hole circle. Then lock the spindle and perform the machining operation. Then repeat another 6 turns and 12 holes in the 18-hole circle. Lock the spindle and machine again. Continue this process until you have gone completely around the circle. This will produce a circle divided into 6 equal spaces. Some indexing heads have more than one set of plates. So if the denominator of the fractional turn cannot be divided evenly into the number of holes on one plate, you can select one into which it will. To divide a circle into 24 equal graduations, 40 divided by 24 yields 1 turn and 16/24 of a turn. Since we do not have a 24-hole plate, reduce the fraction to its lowest form. So 16/24 can be reduced to 2/3. A plate can now be selected with a number of holes which are divisible by 3. The 15-hole, 18-hole, or 21-hole plate will satisfy this requirement. Let's use the 15-hole plate. So 2/3 of a turn would be 15 divided by 3, which is 5, multiplied by 2 equals 10 holes. To make 24 equal graduations, make 1 full turn of the index crank plus 10 holes and mark the position on the circle. Continue the indexing to complete the divisions of the circle into 24 equal parts. Indexing between 2 points, it is better to change circle plates. For example, to get divisions 21 degrees apart, divide 21 by 9 to get 2 turns and a remainder of 3 degrees. By changing to an 18-hole circle and knowing that 1 hole equals 30 minutes, a total of 6 holes will provide the 3 degrees. So for 21 degrees after the first mark was made, turn the crank handle 2 turns and 6 holes in an 18-hole circle to produce 21 degrees between the 2 marks on the circle. The same results could be obtained by working in minutes instead of degrees. 21 degrees are equal to 1260 minutes, and 1 turn of the index crank moves the plate 9 degrees or 540 minutes. Thus, 2 turns will yield 1080 minutes, and the remaining 180 minutes is equal to 1/3 of 540, or 1/3 of 18 holes, or 6 holes. The advantage of going into minutes is that it provides a closer tolerance than degrees. Another method of holding work and dividing a circle into equal parts is with the use of a rotary table. Rotary tables are usually equipped with graduations on the table and the base, so that a circle can be divided into any number of parts using degrees. Some rotary tables have index plates which allow a circle to be divided into minutes. Other rotary tables have different ratios. This particular table has a 90-to-1 ratio, which means that 90 turns equals 360 degrees, or stated another way, 1 turn of the crank equals 4 degrees. The index plate allows accuracy to the nearest degree. For example, on a 32-hole plate, each hole would equal 7 minutes and 30 seconds. Therefore, using the index plate on a rotary table allows for divisions of very close tolerance. In review, the indexing head can be used to perform direct indexing, simple indexing, or angular indexing. The principle of indexing is based on a 40-to-1 ratio of turns of the index crank to turns of the dividing head spindle. The rotary table is another method of dividing a circle into measured parts. Many machine operations in the machine shop require the dividing of circles or the machining of equal parts on a circle. The dividing head or rotary table can be used to accomplish this operation to a very precise tolerance.